Hello. We are going to today go over solving rational equations, and we're going to begin with this one, number one, on your sheet. 7 divided by x minus 6 equals 4 over x. Now, there are two methods for solving rational equations. One in which you cross multiply, which I believe is called method 1, proportions on your paper, and method 2, using the least common denominator. Now, when you have a fraction equaling a fraction, it's probably easiest to cross multiply. So we're going to start with that method. And when we have one that's not quite like this, I'll show you some of those later, we'll use the other method, the method 2 of least common denominator. So with this one, we're going to cross multiply, which just means we're going to multiply the numerator on the right by the denominator on the left, and the numerator on the left by the denominator on the right. So I'm going to get 4 times x minus 6 equals 7x. That is my first step. 4 times x minus 6 equals 7x. I then need to distribute that 4 into that set of parentheses. So I get 4x minus 24. And that will equal 7x. Then I want to collect my like terms. What I'm going to do is I'm going to subtract 7x from both sides. Actually, no. I think I want to subtract 4x from both sides. So we can do it either way, but I think the way I want to work, I'm going to subtract 4x from both sides. So minus 4x minus 4x, if you can see that green. I'm subtracting 4x from both sides. So that will go away here and leave me with just negative 24. Equals 7 minus 4 is 3x. Then lastly, x by itself, I just need to divide by 3. So I have negative 24 divided by 3, and that's going to give me negative 8 equals x. And that's how we solve that. Now, it is possible to get two answers and not just one. It's also possible to get fake answers, or answers that are not allowed. We have with these what was called a domain restriction. So we do need to check our answer to make sure it's not in the restricted one. So we're going to look for a domain restriction. And all that means is we've got to make sure we're not dividing by 0. So we have to take our denominators that we were given and see, will plugging this in make it equal 0? Okay? So x is not allowed to equal 0 because that's the denominator here. And so that is not allowed an answer. But negative 8 is not 0, so that's okay. Our other denominator, x minus 6, is also not allowed to equal 0. If we were to solve that for x, we'd have to add 6 to both sides. So x would not be allowed to equal 6. So our domain restrictions are 0 and 6. Since negative 8 is not restricted, it's an allowable answer. Therefore, negative 8 is our answer. Okay? And that's how we do these problems. I'm going to do one more with you, and then I'll ask you to try one. So we're going to work down. If you look at number 3 on your paper, you should have r divided by r minus 1 equals 4r. Again, we're going to use method 1, the proportion or cross multiplication, where we multiply these two together and set it equal to the other two. Okay? So we have 4 times r minus 1 equals r squared, because r times r is r squared. And it wouldn't matter which side. You could have the r squared here and the 4r minus 1 on the other side. You get the same result. I am going to distribute the 4. I'll get 4r minus 4 equals r squared. Now you guys remember from solving quadratics, and that's what this is. You see the r squared tells you it's a quadratic. You want to make it equal 0 to solve it. So I'm going to need to rearrange this so it equals 0. I'll subtract 4r from both sides, and then we'll add 4 to both sides. So what I want to do is subtract 4r, subtract 4r. I'm going to want to add 4 and add 4. Okay? This will make the side over here equal 0 because 4r minus 4r is 0. And negative 4 plus 4 is 0. On the other side, we're going to get r squared minus 4r plus 4. So there I have a quadratic as you're used to seeing it. And to solve that, I'll just factor it. So 0 equals the factors of 4 that add to -4 are -2 and -2. So r minus 2 and r minus 2 would be the factors there. Then I can set each factor equal to 0, but they're the same, so I know it's only going to be 1. I can set r minus 2 equal to 0 and r equals 2. I need to check again for domain restrictions. Is that an allowable answer? To check for domain restrictions, we just set the denominator and say it cannot equal 0. So r cannot equal 0, that's this denominator. And r minus 1 cannot equal 0. That means r cannot equal 1. Since 2 is not restricted, we can go ahead and say our answer is r equals 2. Okay? I suppose more correctly, we should have the r equals outside there and then the 2 inside. Alright, let's keep working down. Number 5 is next, and I would like you to go ahead and do number 5. Pause the video now and work out number 5. Seriously, pause the video, do it yourself. Okay, so you should have worked it out, and you would cross multiply and get 3 times y plus 8 equals y times y plus 5. You would distribute the 3, distribute the y. You want to rearrange so it equals 0. Therefore, you would subtract 3y from both sides, giving you 2y, because 5 minus 3 is 2. Subtract 24. The factors of -24 give you 2, or plus 6 and minus 4. We set each of those equal to 0, and we get y equals -6, and y equals 4. Therefore, my solution set is y equals -6 and 4. We check our domain restrictions, and it is y plus 5, that, or y cannot equal -5. The y plus 5 cannot equal 0 there. So that is number 5. Okay, let's look at the back. There's something interesting about the back. Number 7 here. Number 7 has 3 fractions. When you have it like that, you can't just cross multiply. It has to be a fraction equaling a fraction. But when you're adding or subtracting some on one of the sides, like here, we have the 4/3 minus 7 over n, we cannot just go and cross multiply that because it's not going to work. You have to have only one fraction on each side. If it were 7n equals 1 over 6, you could, but with this added or on here, we can't cross multiply. We're going to use the other method, known as least common denominator, meaning I have to multiply this through by the least common denominator. Dogs are going crazy over there. I'm going to shut this door. Alright, so you will need to figure out what is the least common denominator. We have an n in the denominator, a 3 and a 6. Well, if you remember, 6 is 2 times 3. So if I do 6n as my least common denominator, I'll have the 6 and the n in there. But buried inside the 6 is a 3, so that takes care of that as well. You want to have what is common to all denominators, but it's as small as possible. So I'm going to multiply through by a 6n. So I have here 4 times 6n over 3 minus 7 times 6n over n equals 1 times 6n over 6, but you typically don't write in the 1. Now, a beautiful thing will happen here. If you look, you can cancel or reduce the 6 over 6, the n over n, and the 6 and the 3 will cancel and make a 2. This will allow you to have 2 times 4 or 8n here, 7 times 6 or 42 there, and that will equal n. So it simplifies just like that. We're going to go ahead and subtract 8n from both sides, so minus 8n minus 8n. So we get negative 42 equals negative 7n. Then we want to divide both sides by negative 7 to get n, and 42 divided by 7 gets us back to n equals 6. Now, we have to make sure our answer is not restricted in the domain. And so let's look for the initial question. What variables were in the denominator? Well, it's just an n. So we know our domain restriction is n cannot equal 0. But it doesn't, so that's okay. So we know that n is equal to 6. And that's it. That's number 7. We'll continue working down. Let's look at number 9. It's p divided by p minus 2 plus 2 equals 8 over p squared minus 4. Getting the least common denominator here could be a little bit tricky. But look, we can consider a few things. That number 2 is technically over 1. So 1 will be included in anything you make for a denominator. This one has a p minus 2. What can you factor p squared minus 4 equal to? If you remember, that's p plus 2, p minus 2. We factor that by difference of squares. We're going to get p plus 2, p minus 2. And that would actually be the least common denominator, because if we take p plus 2, p minus 2, it contains this denominator. Obviously, anything times 1 is itself. And the p minus 2 is right there. So what is common, and it has the parts of every denominator, is p plus 2, p minus 2. Okay? We're going to multiply that across. And what will we get? We'll get p times p plus 2, p minus 2, over p minus 2, plus 2, p plus 2, p minus 2. That's over 1. And then we're going to get 8. I'm running a little bit out of room here. Times p plus 2, p minus 2. And all that's going to be over p plus 2, p minus 2. Now, if you remember what's going to happen when you have factors on the top and the bottom, they will cancel. So that p minus 2 over p minus 2 will cancel. The p plus 2 over p plus 2 will cancel. And the p minus 2 over p minus 2 will cancel. This makes what we have left much simpler. I will distribute this. We'll get p squared plus 2p. Once I distribute that p into the p plus 2, the p minus 2's have canceled. So then we have plus over here. We would have to FOIL this and then multiply by 2. So I'm going to keep the 2 out front, and then I'm going to FOIL. I'll get p squared minus 2p plus 2p minus 4. And that will all equal 8. Okay. We have to then distribute the 2 into there. So I'll do that in the next line. P squared plus 2p plus, let's see, 2p squared. The minus 2p plus 2p will get rid of each other. And 2 times negative 4 is negative 8 equals 8. So we've got to put this together into, we see it's a quadratic because we've got p squareds. We want to make it equal 0 so we can solve it. So let's go ahead and collect. We have 2 plus 1, or 3p squared, plus 2p. And we'd subtract 8 from both sides, giving us minus 16 equals 0. So then we'd have to factor that, or we could use the quadratic equation. But 3 times 16, let's see what that would be. 3 times 15 would be 45. And so 3 more than that would be 48. And we look for the factors of 48 that gave us 2. That would be 8. 8 and 6, right? Yeah. 8 times 6, where the 6 was negative, because it would actually be a negative 48. So 3 times negative 16 gives you the negative 48, and that factors to 8 and negative 6, which add to 2. That is going back to factoring by trinomials. I'm running very low on my paper, so I'm going to grab a blank sheet here, and we will use this to keep working. Let me copy down what I have so far. We have 3p squared plus 2p minus 16 equals 0. And we have that negative 48 factors to 8 and negative 6. All right. So let's see here. If we want to factor this, we'd have to take the 3p squared and replace the 2p with minus 6p plus 8p. Minus 16 equals 0. Then I'm going to factor that by grouping. I'll group the first two. I'll group the second two. We'll factor a 3p out. That'll leave me with p minus 2. I'll factor an 8 out here. That'll leave me with p minus 2. There's a plus. And then we factor the p minus 2 out. And we get 3p plus 8 times p minus 2 equals 0. We want to set each of these equal to 0 now, each factor. P minus 2 equals 0, and 3p plus 8 equals 0. So this is just like we did when we solved the quadratics before. Here p will equal 2, and we'll subtract 8, get 3p equals negative 8. And therefore p equals negative 8/3. Okay, we finally arrived at our answer, and we're ready to check for domain restrictions. Now, the original one, if you recall, had p minus 2 and p squared minus 4 as the denominators. So the restricted domain would be the, is it p minus 2 or plus 2? P minus 2, right? P minus 2 cannot equal 0. So what is restricted is p cannot equal 2. Wait, that was one of our answers, but that answer is not allowed. So we must only use the other one, saying p equals negative 8/3, and the other answer was restricted or not allowed. We could do that. All the other denominator was the p squared minus 4. So we can look at that as well. P squared minus 4 cannot equal 0. We'd add 4 to both sides, so p squared is not allowed to equal 4. You square root 4, and p is not allowed to equal 2. So you do get the same result. We can't equal 2, and actually when you square root it you get the plus or minus, so it can't equal plus or minus 2. But that answer of 2 is restricted, so we're only going to use the negative 8/3. Go ahead and pause it now. I'd like you to do number 11. Go ahead and pause it and then do number 11. So here we have x plus 6 over x plus 3 equals 2, minus 5x plus 12 over x plus 3. Nice, easy common denominator there of x plus 3. We'll multiply that through and then cancel, and we get x plus 6. 2 times x plus 3, and minus is the quantity of 5x plus 12. You're subtracting that whole numerator. The x plus 6 stays in the next line, but I'm going to distribute the 2 and get 2x plus 6 minus 5x plus 12. We'll get the quantity. Then we have to collect our like terms. So over here I have 1x. I'm going to subtract 2, giving us negative x, but then I have to add 5, so then we got 4x. The plus 6, and then we subtract 6 from both sides, so those are going to take care of each other or cancel each other out, and we're left with the negative, once you distribute it, 12. Dividing both sides by 4, we get x equals negative 3. Then when you check your domain, negative 3 is restricted. So number 11, the answer is no solution. And there you go. Those are the odd numbers on today's sheet.